Welcome back. One last thing to talk about. Measuring earthquakes. There's a few different ways to do it, and we'll talk about a couple. Before I proceed, let me give you part of the super secret code. It is the number 0. You got me? The number 0. One more time, the number 0. One way to measure an earthquake is using something called intensity. And for this class, the intensity scale we will use will be known as the modified Mercalli intensity scale. It measures the maximum intensity of shaking at a location. It's basically what you feel and what you see happening around you. Because the shaking varies from place to place in a given earthquake, so does the intensity. So let's say an earthquake happened right below Avondale. Well, I would feel some sort of shaking. I would see some sort of destruction. But if you ask someone in Tempe, 20 miles away, what did they feel? It would be something different, something much less than what I felt here. So this measurement scale, during one earthquake event, can vary. The measurement can vary from place to place. And again, it's based on descriptions, what people feel, see, the damage that's occurred. And the scale differs with distance from the epicenter. If the focus is below Avondale, then the Avondale would be the epicenter. As you get further away from Avondale, the intensity scale, the intensity of what was felt or the damage done, becomes less and less and less the further you get away. It's measured on a scale from 1 to 12 using Roman numerals. And this is more meaningful to the non-scientist. Let me explain why. What you hear about in another, in here in a little bit, is a different type of scale. And that uses fancy measurements, mathematics, science, all kinds of fun, sciencey, mathy stuff. Whereas the intensity scale is just based on what you feel, what you see. So based on the earthquake, oh man, I felt some shaking and my bookcase fell over and this happened and this happened. Based on those events, what was felt, what you saw, the damage done, you just compare that to this scale and it can figure out, well, how big of an earthquake was it? So, for instance, if the earthquake was felt by all, if many people were frightened and ran outdoors, if walking was kind of unsteady, if windows and dishes and glasses broke, books falling off of shelves, heavy furniture may have moved or turned over, then it was probably a strong earthquake. So it's just based on what you see, what you feel. You don't have to measure anything fancy. You don't have to have any fancy equipment. It's just what you see and what you feel. That's different than the Richter magnitude scale. Sorry, there's a little hiccup there. So that differs from the Richter magnitude scale. This is something totally different. The Richter magnitude scale measures the total amount of energy released in the earthquake. It's not based on what you see, feel, detect, sense damage. It's just based on some measurements of total energy released. So it's related to the area of the fault on which it occurs. The larger the area of the fault, the larger the earthquake. So some faults are small, some faults are kind of rather large. So it's also based on that. But you take all of these measurements and it's kind of based on the recorded heights or amplitudes of the seismic waves recorded on the seismograph. If I've already lost you, I totally get it. If I've already lost you, I totally get it. That's because, again, this Richter magnitude scale, it's more meaningful to the scientist. It's more meaningful to the scientist, but to the non-scientist, it's kind of weird. This Richter magnitude scale exists on something called the logarithmic scale. When's the last time you heard a logarithmic scale? I mean, it's mathematics. And for example, so Richter magnitude scale, let me pause and go back a second. So the Richter magnitude scale, this is what you typically hear on the news, what you see on a movie. It's when you hear on the news, oh, there's a magnitude 7.0 earthquake occurred in Los Angeles. They're referring to the Richter magnitude scale. Or if you hear it on a movie. So for example, The difference between a Richter magnitude 7 earthquake and a Richter magnitude 8 earthquake is that there's 10 times more movement in that step up of 1 magnitude and 32 times more energy. So what logarithmic means though, right? So if I'm making 2 steps from a 7 to a 9, it's not 10 plus 10, so 20 times more movement. It's multiplicative. It's multiplied. So 10 times 10, so it's 100 times more movement between a 7 and a 9. And then same with energy. It's 32 times 32, so 1,025 times more energy. And typically with a Richter magnitude scale measurement, there's one measurement for the entire earthquake. It doesn't tell what kind of damage, what kind of destruction, what was done. It's just a measurement of energy along how big of a fault line. So what does that mean to me? Does that mean my house is going to fall over? Does that mean, it's dangerous? Well, what does that mean? So to a non-scientist, it has little meaning. To a scientist, it's telling you a lot about energy and distance and length and a number of different things. But yeah, we'll look at both of those scales. It's very common that the news talks about earthquakes in terms of Richter magnitude, when really they should be talking about possibly the Mercalli, modified Mercalli intensity scale. Looking at Richter magnitudes up to a 10 and comparing them to energy equivalent, between a 3 and a 4 magnitude earthquake on the Richter scale, similar amount of energy to a large lightning bolt. So if a large lightning bolt goes off and strikes near your home, your walls can rattle, dishes can shake. As you get kind of further up, between a 4 and a 5, about average tornado energy, 6 to 7, that's the energy released in the Hiroshima atomic bomb. 7 to 8, up into 9, largest nuclear tests, some of the larger volcano eruptions that have ever occurred. And then once you get 9 or above, there's really not many things on Earth that have that sort of energy equivalent. So looking at just a handful of earthquakes that have occurred really at 9 or above, that's pretty devastating. So when you're trying to figure out the magnitude, again, what you're looking for is what's known as the SP interval, or that's S minus P time. So whatever time the S wave arrived at, minus whatever time the P wave arrived at. In this case, looks like 24 minus 0 or minus 1. So maybe 23 or 24 seconds. That's where it would be on this scale here. The other side is distance. In this case, I'm just going off information I know from this seismogram. So 23 or 24 would be somewhere in here. I also can measure the amplitude, the biggest peak of the scribbles. What's the height of that? In this case, 23 millimeters, which would be somewhere over here. You just draw a line between the two, and that would indicate the magnitude of the earthquake. So that'd be a magnitude 5.0 on the, or 5.1 maybe on the Richter scale. So what does that tell me? Does that tell me things were destroyed or damaged? Nope. It's just a reference of about how much energy was released based on these factors. Interesting to the scientist, maybe not so to the non-scientist. You want to know where the damage is, where the things have occurred, etc., etc. So looking at the largest recorded earthquakes. So of the 17 largest recorded earthquakes, where are they? They're all around the Pacific plate, all around the Pacific Ocean. The major reason for that, along this portion of South America, convergent boundary. Alaska into Asia, convergent boundary. Through Asia, down through Indonesia, convergent boundary. So you have all these convergent boundaries where there's some sort of subduction occurring. That's where you're going to get the biggest earthquakes. The biggest earthquake ever recorded with the Richter magnitude scale was in Chile in 1960 at 9.5. Alaska, 1964, 9.2. Off the coast of northern Sumatra, so Indonesia, 2004. Happened just after Christmas, 9.1. A couple of 9s, but in recorded history, above a 9.0, there's really only been 3. When you're getting up into these levels, That's a lot of energy released. So what's the maximum magnitude that could occur on the Richter magnitude scale? The Mercalli scale is just from 1 to 12. Well, since this is based on measurements, there's a maximum to some of these measurements. Even though the magnitude scale is somewhat open-ended, meaning that scientists have not put a limit on how large an earthquake could be. Just because the largest one's been a 9.5 doesn't mean one couldn't be a 10.2. However, there is a limit just on the size of the Earth, and some of the distance and length measurements required to calculate the magnitude of an earthquake, well, you can only go as far as, or however big the Earth is. You can't do any measurements bigger than that. It's the Earth that's creating this earthquake. So because of that, a magnitude 12 earthquake would require a fault larger than the Earth itself, so that really can't happen. Yeah. Fun stuff. Before we go, let me give you another part of the super secret code. It is the number 2. One more time, the number 2. One more time, the number 2. And with that, I bring you to the end. We'll touch on a lot of this stuff in class and in lab. So we'll work with this information a little bit more, some of these different measurements, these different scales, etc., etc., etc. In the meantime, if you have any questions, let me know. But if not, until next time, I'll see you then.